Hello everyone. Today we will try to cover some of the topics in the chapter units and measurements. First, the need for measurement. I had given a video, please check in the classroom. Then units of measurement, system of units, SI units, fundamental and derived units. We will try to discuss about these small topics, right? Now when we come to units and measurement, uh, first let us see some of the terms which we have to understand. That is characteristic, a typical feature of something. When we often use the term characteristics in while going through the chapters, while talking about certain theories and all, going through the chapters while studying some theory, you will come across these terms which it is very important to understand them. The first one is a characteristic, means a typical feature of something. Compare the vehicles below. This is a vehicle, okay, it's like a car but longer one, big one, and this is an ordinary car. This is limousine and this is an ordinary car. Now the second term is property, something that gives an object its characteristics. I pasted here some picture. That this is a picture of a rubber band. Rubber band has certain characteristics. When it is pulled and released, what could you say is characteristic of objects made with the same type of material? Ultimately, what can you say is the property of rubber? Rubber is not only the elastic material, that also you should know. Spandex used in stretch jeans is another example, okay, of an elastic material. So property. Next is physical, something that is real in the sense that it can be seen, felt, etc. Not imaginary, but keep it in mind, it is never imaginary. Whenever we talk about physics, physical theories and all the definitions related to physics, we never talk about imaginary things. Okay, for instant, for an initial stage we can imagine something, but afterwards we have to physically prove that, and can thus be described in terms of what you observe or perceive. Okay, consider the following. You can feel the effect of force throwing you off as you stand at the edge of a merry-go-round while it is spinning, and here also when you are pulling that rope, you can feel the force of the opponent, right? Now there are two lines here. You can physically see कि one line is longer than the other. Next is a quantity, something that can be quantified, given a number to. I have 2 chocolates, I have 2 pens, there are 4 apples. So that number, that quantity. Now when you talk about a physical quantity, the physical property that can be expressed in numbers, for example, length being quantified. Length being quantified means, suppose I say 13 centimeter, that 13 is the quantified, the length is quantified. How much? 13 centimeter. Units, actually in earlier times, scientists of different countries, they used to use, they were using different actually system of unit. Now one of the system of units was CGS system. CGS means centimeter, grams and seconds. Then FPS system was also there in Britain and all. FPS system was used. FPS means foot, pound and again seconds. Then MK system was also there. MK system means meter, kilogram and seconds. Now presently what is happening is, the present international system of units, they are trying to use this one. Which one? MK system. It is known as standard international units of systems, and here meter, kilogram and second they are taking it as. That is MK system they are using. Now, why SI units are required? What is the reason? Because they are facilitates international trade and communications. Because whenever you are using one language for communication, it is always required that the language should be common. Similarly, when we are using units for a certain quantity, for measuring certain quantity, if the language, the units are not same, then it is difficult to understand this side also and that side also if there is difference. And second thing is that it facilitates exchange of scientific findings and information. Something someone had found there, and it is mentioned in quantities. If the units are not mentioned, if the units are not if I can't understand the unit, so naturally I can't understand what is the scientific findings. So it is very important that the unit should be common. Okay, next, physical quantities. These may be divided into two quantities and derived quantities. Base quantities are expressed in base units, and derived quantities are expressed in derived units. Now there are 7 base units. 7 base units, let us see what are the 7 base units. Length, the symbol is L and the unit is meter. Abbreviation mein small m we write it as, and mass, small m symbol, and kilogram, and we write it as kg. Time, small t, seconds, and we write it as small s. Electric current, capital I, ampere, unit of electric current is ampere, and abbreviation is capital A. Thermodynamic temperature, capital T, Kelvin, and capital K is the abbreviation. Amount of substance, the symbol is N, unit is mole, and abbreviation is MOL. You know amount of substance, you must have studied in chemistry. Now luminous intensity. Luminous intensity means the light which is coming, which is falling somewhere. If we want to find the intensity of light, we call it as luminous intensity. That is, the symbol is IV, and the unit is candela, and the abbreviation is CD. You have to take care of these points and note this in your copy also. Next, common SI prefixes for units. You can go through this table once. It is very important when you talk about the prefix which you use while measuring something. That is nano, 10 to the power minus 9, micro, 10 to the power minus 6, milli, 10 to the power minus 3, centi, 10 to the power minus 2, then deci, 10 to the power minus 1, kilo, 10 to the power 3, then mega, giga, tera, peta. These things you have to keep it in mind. Please note down this also. Multiples and submultiples, please go through this table once. 10 to the power 3 meters is 1 kilo, is actually 1 kilometer, that is kilometer. 10 to the power minus 9 minus 1 meter, that is decimeter. Okay, go through this once. When we talk about the conversion between multiples and submultiples of a base unit, how can you convert from kilometers to meters? So kilometers to meters means, you already know. When you know this table, when you know this one, you can easily find out how can you convert kilometer to meter. 3 kilometers. Similarly, you can also convert from meters to kilometers. Quite opposite to that. If you want to convert 70 meters to kilometers, so simply what you have to do is you have to multiply 1 by 1000 of kilometer. It's a unitary method. You already did in your previous classes. Nothing new. Convert 45 millimeter to meters. Similarly, 1 by 1000 of a meter is 1 millimeter. So you multiply that with 45, you will get 0.045 meters. right? Again, convert 13 millimeter to centimeters. You can convert, no issues. How to convert from centimeters to millimeters, that also, because it's a centimeter and millimeter, you know how many centimeters are having how many millimeters. So 1 centimeter is having 10 millimeters. So similarly you can easily calculate by 1 by 100 of a meter, then you can convert into 115 millimeters, right? 11.5 centimeter to millimeters, if you want to convert, you are simply multiplying 10, then you are getting 115 millimeter. Am I right? Okay. Then derived units, what are SI derived units, derived quantities and units? The derived units are defined as products of powers of the base units, and there are derived units expressed only in terms of base units. For example, if I say square meter, it is meter ka square, meter into meter, right? And if I say meter per second, it is meter divided by second. Now there are also derived units with special names, usually names of scientists, symbols for the units, you know, Newton, Pascal. Now if you see this area A, what is the derived unit? Yeah, derivation, it will meter into meter becomes area. Volume, meter square into meter. Speed, meter divided by second, meter per second. So these are all the derived units. In some cases you can see force, you are writing kg meter per second square, and that is equal to Newton. So that much is equal to Newton. So this Newton, Pascal, Joule, Watt, Coulomb, then volt, ohm, all these are the names of scientists. So do you know the full names of scientists after whom the following units were named? Newton, Pascal, Joule, Watt, Coulomb, Watt, volt and ohm. Let me give you this question in the classwork. Try to write the names of the scientists, because these scientists have given the world their famous inventions and discoveries, and because of that only we have given the names of their names itself as the units. So it is very important to know their full name, right? So try to find out the names and write in your copies. Right, next. Let us take a break.
The young people to understand how to manage the failure, because any task you do, you have to come across problem. Problem should not become the captain of the individual or the project chief. The project chief should become the captain of the problems and defeat the problem and succeed. Learning gives creativity. Creativity leads to thinking. Thinking provides knowledge. Knowledge makes you great. History has proven that those who dare to imagine the impossible are the ones who break all the human limitations. In every field of human endeavor, whether science, medicine, sports, arts or technology, the names of the people who imagined the impossible are engraved in our history. By breaking the limits of their imagination, they change the world. You take C.V. Raman, you take Newton, you take Einstein, you take Chandrasekhar. By breaking the limits of their imagination, they change the world. If you want to be discoverers, if you want to be innovators, I am going to give you what type of characteristic you must have. Invention and discoveries have emanated from creative minds that have been constantly working and imaging the outcome. The telephone, he was imaging the outcome in the mind. With imaging and constant effort, all the forces of the universe work for that inspired mind, thereby leading to invention, discoveries.
Sir, I would like to hear from you a few tips for the upcoming generation to succeed in life.
Well, succeeding life, I have already told you.
Yes, sir.
You have to do 4 things, okay? Number 1, great aim.
Great aim.
I will have great aim.
I will have great aim.
I will
I will
continuously acquire knowledge.
continuously acquire knowledge.
I will do hard work.
I will do hard work.
I will persevere
I will persevere
and succeed.
and succeed.
Okay, that's the mantra.
Thank you, sir. Thank you so much.